Hello student, myself Rakhi Kumari, Assistant Professor in the Department of Electronics and Communication Engineering, ABES Engineering College, Ghaziabad. Today, we will have a lecture on the transmission line. And in this particular section, we are going to deal with the reduction of the transmission line. Further, we will have some more concept and some more derivations, equations, etc. related to transmission line, numericals related to transmission lines, and the gate questions related to transmission line with its explanation. Now, the content which has to be covered in today's lecture is the categories of medium of propagation, different types of bounded media propagation, difference between transmission line and a waveguide, and types of transmission line. Now, in the introduction section, we will have the wave propagation divided into two categories. First one is the unbounded media propagation, and the second one is the bounded media propagation or the guided wave propagation. So, unbounded media propagation means a free space propagation, free space wave propagation. That means wave is free to move wherever it wants. That means it is uniform throughout all the space. That means in the x direction, in the y direction, or in the z direction, it will remain uniform throughout, and it is free to escape wherever it wants. There is no restriction, and it is not bounded by any rules or any set of directions which can describe where you have to go. And also, there is one disadvantage over it, that it is not guided by anything. That is where you have to go. It may go to the definite direction, or with the direction where the receiver is there for its reception, or it can go anywhere. And second thing, the energy spread over a wide area. What does it mean? That means when we talk about the bounded medium and it is of 2 meter, that means it will move up to 2 meter only. It will not go beyond that. And if it is directed to move in the horizontal direction, it will move in the horizontal direction. It will not go to the vertical one. But in the case of an unbounded medium, it will go beyond 2 meter. It will go in the vertical direction also. Because there is no any bounded condition for its propagation. And this type of propagation is used in radio or TV broadcasting. Now comes the bounded media or the guided wave propagation. The guided wave propagation means that it is bounded by some definite set of rules, and it has got a guide which can guide it where to move and in which direction and up to how much distance. So, the propagation of plane waves in the guided wave propagation takes place between boundaries. These are the boundaries, and the wave is made to propagate between this boundary. And the boundaries which are associated with the bounded media propagation is the conductors. And this type of propagation is used in telephones, transmission of electrical energy from a generating station to the load centers, connection between a transmitter to the antenna, connection between computers in a network. Now, there are two kinds of wave guiding system. First one is the transmission line, the second one is the waveguide. Now, let's have a difference between a transmission line and a waveguide. The first difference is that the waveguide transmission line is a conductor or a wire which is used to carry electrical energy below microwave range. But in the case of a waveguide, it is a hollow metallic pipe designed to carry microwave energy. This is one of the basic difference and the most important difference between a transmission line, that a transmission line is used in the range of below microwave frequency and the waveguide is used in the range of microwave frequency. The second most important one is the transmission line are made up of two or more conductors by some insulating medium in between the two conductors, which are used to separate the two conductors. But in the case of a metal waveguides, basically it is enclosed in one conductors which is filled with a insulating medium. So we can easily see the difference. Here it is 2 or more, and in the waveguide it is 1. Both we have an insulating medium. Here the two conductors are separated by insulating medium, and here the conductor is filled with an insulating medium. Now, in the transmission line, basically associated with the signals below the microwave range, that is of the electrical one. So, for the analysis of transmission line, circuit theories are used, but waveguides are associated with waves only. And so, for the analysis of a waveguide, wave theory is, this is the third most important difference between a transmission line and a waveguide. Next one is the power handling capacity is low in the case of a transmission line, and the power handling capacity is high in the case of a wave. The characteristic impedance, one of the most important parameter in the case of a transmission line, depends upon the physical parameter of a transmission line, that its length, its width, its other parameters which are associated with the physical quantities of a transmission line. But the wave impedance, which is synonyms to the characteristic impedance of a transmission line, is a function of a frequency in a case of a waveguide. In transmission line, electrical signal is associated, but in the case of a waveguide, electromagnetic signal is associated. Now comes the further difference between the transmission line and the waveguide. The operating frequency in the case of a transmission line is up to 18 GHz, but in the case of a waveguide, the operating frequency is from 3 GHz to 100 GHz. Now, the normal operating mode in the case of a transmission line is TEM, that is transverse electromagnetic wave. Or quasi TEM wave mode. It can support TE and the TM. TE stand for transverse electric and the TM stand for TM, transverse magnetic mode. But these modes are typically undesirable in the case of a transmission line. But in the case of a waveguide, the operating modes are TE and the TM only, that is transverse electric and the transverse magnetic mode only. It cannot support a TEM mode. So this is one of the most important difference between a waveguide and a transmission line again. Then another difference, the two-wire transmission line have a large copper area due to small surface area. And in the case of a waveguide, the large surface area of a waveguide reduces copper losses. Now, the dielectric losses are more in the case of a two-wire transmission line, and also the dielectric losses are less in the case of a waveguide. The significant signal attenuation at high frequency occurs in the case of a transmission line due to conductors and the dielectric losses, but which we have already seen in the previous two difference, and the lower signal attenuation at high frequency than the occurs in the case of a waveguide as compared to the transmission line. The transmission line, all frequencies pass through, but in the case of a waveguide, it acts as a high pass filter. So only the frequencies above a particular frequency, which is called as the cutoff frequency. So we can say in the case of a waveguide, the signals which are above the cutoff frequency is only allowed to pass, and this cutoff frequency is decided by the parameters, or we can say physical parameters of a waveguide. Now comes the type of a transmission line. Transmission line is basically of two types. The first one is the two-wire transmission line or parallel wire transmission line. Two-wire transmission line is consists of a pair of parallel conducting wires separated by a uniform distance, and it is used in power system or telephone lines. You can say that there is a two conductors parallel, and it is separated by a uniform distance, and it is called as the two-wire transmission line or a parallel wire line. The second one is the coaxial transmission line. This is generally used at high frequency. It consists of two conducting concentric conductor which is separated by an insulating material. First one this and the second one is this, and in between we have a insulating material. This is a case of a coaxial transmission line. The outer conductors, which is this one, forms a shield and it confines the wave between the conductors. Waves are confined in this region, which is between the two conductors. In this, the electric and magnetic fields are only confined to the dielectric region, which is the dielectric region is between two conductors. Energy loss due to radiation is quite small in the case of a coaxial transmission line. The losses in the dielectric medium increases with frequency. Coaxial lines cannot be used at frequency above 1 gigahertz. Basically, further in the lectures, we will have a study of the two-wire transmission line in details, and then we will move to other form of a transmission line. These are the references for this lecture. Thank you for watching this lecture.